Okay, geometry class, welcome to your very first lesson in which I'm recording your lesson, and you can watch it, you can take notes, you can pause and rewind the video, or later on when you're doing your homework, you can come back to this video at any time and rewatch any part of it that you need to see. So I ask that you take notes on your guided notes that accompany this video, and take very good notes. Remember, you're taking notes for you so you could understand these later on tonight. So we're going to talk today about the three basic trigonometric functions. Now this word trigonometric refers to trigonometry. The tri part is triangle, and metric means to apply a measurement to. So trigonometry is literally finding the measurement of triangles. And you actually already know one trigonometric function, and that's the tangent function. We spent a lot of time in this last unit studying tangent, which was the ratio of the side opposite, where you're standing, to the adjacent side. And there are two other basic trig functions. But before we get to those, I'd like you to take a look at this little story that I have right here. This story says, some old horse caught another horse taking oats away. I'm sure you're kind of surprised that I'd start out this lesson with such a sad story, but I want you to read it again out loud to yourself. Feel free to whisper so people don't stare, but let's say it again together. Some old horse caught another horse taking oats away. Now I'm going to cover that up, and I want you to say it again to yourself. Don't look at what you just wrote down, but I want you to just say it again from memory. Good. Did you say, some old horse caught another horse taking oats away? Good, good. Now we'll come back to that story in just a minute, but let's dive into these three trigonometric functions. So first of all, these three trig functions will only work if you have a right triangle. And so here's a right triangle, and I'm going to say for now, we're going to learn maybe some tricks, but for now, let's just focus only on right triangles. And here we have our angle. Now you'll notice I'm using this fancy Greek letter. This is the Greek letter alpha. And in upper level math classes, what we often do is, instead of using x's or y's for angles, we use Greek letters. And so this is just the Greek letter alpha. And so we have these three ratios down here. Now you'll notice the bottom ratio is the tangent ratio, and we already know how to use that. Remember from our last unit that tangent is a function, and it only exists if it attaches itself to an angle, because that angle gives you reference point. So let's pretend that we're focused in on this angle. We're standing right here at the angle called alpha, and the tangent function, you remember, is the ratio of the opposite. Before we get there, the abbreviation for tangent is TAN. So this is read the tangent of alpha, and it's the ratio of the opposite side to the adjacent side. And we spent a lot of time on tangent. Well, now we're going to introduce two other trig functions, and these are sine and cosine. Again, these are trigonometric functions, so they have to attach themselves to an angle. That angle provides a reference as to where you're standing. So the sine of an angle, which is abbreviated as the sine, in this case of alpha, is the ratio of the opposite side to the hypotenuse. So standing here, it's the ratio of the side opposite where we are to the hypotenuse of a triangle. Now remember, the hypotenuse of a triangle is always the side opposite the right angle. The third of the three basic trig functions is the cosine of an angle, and it's abbreviated COS, so this is read the cosine of alpha, and it's the ratio of the side next to where you're standing, or the adjacent side, to the hypotenuse. So these three trig ratios all apply to where you're standing. You have to figure out where you are. And then you define in that triangle the side opposite, the side adjacent, and of course the hypotenuse never changes. It's always opposite the right angle. Now I know you're looking at this thinking, oh my gosh, that's a lot to memorize. But watch this. If we take just the first letter of each word. We would have sine is the opposite over the hypotenuse. Just the first letter, cosine is the adjacent over the hypotenuse. And of course, tangent is the opposite over the adjacent. Some old horse caught another horse, taking oats away. So let's dive into some problems, and you're going to amaze yourself with what you already know how to do. We've already worked with trig functions when we worked with the tangent function. We just have two new functions that will get us answers a little bit faster in some cases. So the first thing I do every time I have to work problems with right triangles and trigonometry is I write out my abbreviations. Some old horse caught another horse, taking oats away. And so I look at this right triangle here and I say, okay, well, what do I have? Well, I have this side right here. And what's that side always called because it's opposite the right angle? Well, it's always called the hypotenuse. And then I know that this angle right here is 20 degrees, so I'm going to stand right there at that 20-degree angle. And looking out from that 20-degree angle, what do we call x? Well, we call x the opposite side. And that would make y the adjacent side. So we can choose which variable we go after first. And I guess we'll just go after x first for no reason other than it's there. So standing at 20, you see x, which is opposite, and you see the only other side we know, which is 8, the hypotenuse. Which one of these three trig functions deals with the opposite and the hypotenuse? Well, I hope you said sine. So over here I can write the sine of 20. Again, remember, trig functions attach themselves to an angle, is the opposite over the hypotenuse. Now, just like when we did tangent functions, our goal is to get the x by itself. So we're going to multiply both sides in this case by 8. So I'm going to multiply this by 8. And I'm going to multiply this side by 8. And we end up getting that x equals 8 times the sine of 20. Because, of course, you know that those 8's canceled out. And so we go to our calculator now. Let me pull up my little calculator. I'm going to type in 8 times the sine of 20. And that gives me 2.74, let's say. And that's our value for x. It worked just like tangent, but whereas tangent involved an opposite to adjacent ratio, sine involved opposite to a different side, in this case the hypotenuse. Now, we have to go after y. We're still standing here at 20, but this time we're dealing with an adjacent and a hypotenuse. So which of these three trig functions deals with the adjacent and the hypotenuse? Well, that's cosine. So I can say the cosine of 20 equals the adjacent over the hypotenuse, or y over 8. Some of you are already there now. Y equals 8 times the cosine of 20. And we can go into our calculator and type in 8 times the cosine of 20. And that gives us about 7.52. So y is about 7.52. Again, notice for each variable we have three things that I do ask you show every time. The original trig function, what you're typing into your calculator, and the answer. But see, this is just like what we did for tangent. As a matter of fact, let's keep going. Example 2. Again, I like to have these some old horse caught another horse taking oats away at the top of my page. We are going to stand right here at the 47 degrees. And looking out, we see this side that's 8. And that side that's 8, that's the opposite side. We know y is the adjacent side. And we know x is the hypotenuse. So let's go after, in this case, it doesn't really matter, but I think I went after y first. So standing here at 47, we see opposite, adjacent, that's the tangent function. So the tangent of 47 is the opposite over the adjacent. Some of you are in the shortcut club, but we have to get y alone. You might want to pause the video and see if you can get y by itself. Hey, welcome back. I hope you paused the video, but I got y equals 8 divided by the tangent of 47. I go into my calculator, I type in 8 divided by the tangent of 47, and I got about 7.46. So y is about 7.46. So we found y. Now we're going to go after x. And so standing at 47, we have the opposite side, which is 8, and x, which is the hypotenuse. Opposite, hypotenuse, that's sine. So the sine of 47 is the opposite over the hypotenuse. Again, you have to solve this for x. You might pause the video. I got x equals 8 divided by the sine of 47. In your calculator, by the way, some of you in your calculator might notice these shortcut keys, alpha F1, gives you the fraction shortcut. You can type that in as a fraction. It's kind of a nice little thing to know. And we get 10.94 for x. So x is about 10.94. Again, this is a lot like what we did for tangent. We just have two new functions, sine and cosine. One more problem to try together. And this time we're looking for their angles. So this time I'm looking for x and y, which are angles. Again, starting out, some old horse cut another horse, taking oats away. Let's go after x. So standing where we are, we have 8, which is the opposite, and we have 20, which is the hypotenuse. So opposite and hypotenuse, that's sine. So I'm going to say the sine of x is the opposite over the hypotenuse. Now, this is a little bit different. What do you think the only thing is out there that's strong enough to get rid of sine? Well, I hope you said the inverse sine. So we take the inverse sine of both sides. Inverse sine cancels out sine. So, if you were writing this out, you might take the inverse sine. Oh, my writing is so bad. Of both sides. Ooh, boy, that's terrible. The inverse sine of both sides. And inverse sine and sine cancel out, and we're left with x equals the inverse sine of 8/20. So going into my calculator, I'm going to type in the inverse sine of 8/20, and I get it's about 23.58 degrees. X is about 23.58 degrees. So now that I know what x is, how do I find y? Well, I could set up a whole new trig ratio, but this time, if we're standing at y, 8 is no longer the opposite side, 8 is the adjacent side. So if I were going to find y using trigonometry, I would want to use the adjacent and the hypotenuse, which is the cosine. But there's an easier way to find y. What do all the angles of a triangle add up to be? So I could just take 180 degrees, subtract this 90-degree angle, subtract this 23.58 degree angle, and I could find y just by subtraction. So we worked through 3 problems together. Tonight, I want you to make sure that you show the 3 necessary steps on each problem. Remember, the original trig function, what you're typing into your calculator, and what the answer is. But before you get your homework, I want you to try practice problems 4, 5, and 6 at the end of your notes. The answers to those problems are right there on your notes in the box. Try those, make sure you're doing well, and if you need to rewatch anything on this video, that's what it's there for. Rewatch it. Good luck.